All right, guys, we're going to go on and get started with the notes. So we're finishing up the notes today. Today is going to be the last one. Yes. So I believe this is where we got to yesterday. C. Okay. We did not get to finish C. Or we might have here. We can go on and start here. That's fine. We get to see it again. So what this is wanting us to do is to take the interval or our set builder notation and graph it. So again, brace x bar, the set of all real numbers x such that, because unless we have something specifically there, it's going to be the set of all real numbers, such that x is less than -2 or x is greater than 0. We have our two main statements. As long as one of them's true, those numbers work for this set. Now our two endpoints are at -2 and 0. Now with OR statements, we can go on and throw it in, especially with these compound inequalities. We call it a compound inequality as if we have more than one inequality statement. So our ones that say like -3 is less than or equal to x is less than 4 is a compound inequality. It has two main parts. So for this one here, or compound inequalities, we can go on and just throw them in. So our x is less than -2. The circle would be open and we would shade to the left. X is greater than 0. We would shade to the right. Now the ones that we do have to be careful with is our and statements. And is normally when we have x in the middle. If x is in the middle, we're good, we're fine, we shade. The and statements with inequalities we have to be careful of is if it looks like this one here, but instead of having or between the two statements, it has and. Because we got to make sure that it does overlap. And has to have something in common. It has to be both. It has to make both statements true. Okay? Because just because it makes one statement true does not mean it will always make both. So the and statements we do have to be careful with. Most of the time when that comes up, we're talking about absolute value inequalities. Some where we have two statements and we're just trying to see where is the overlap. But any questions on C? Now C, it didn't ask this, but if we wanted to try to write this as a interval notation, we have two parts. Because we have the left side, this x is less than -2, and we have the right side, our x is greater than 0. If we looked at the left side, the x is less than -2. Well, we know our one key point for this is -2. And since it's going to the left, it's going to negative infinity. Our negative infinity would have the parentheses. Our -2 would have a parentheses. Because that would be that interval. Yes? Questions on how I got that interval? We understand how we would write that? Okay. Now the other statement we have is that x is greater than 0. Our main one endpoint is at 0, and it's going to infinity. And again, both of those would have parentheses. Yes?
Would it always go to infinity?
If it's going in one direction, yes. If there was another endpoint, so the question is, would it? Yeah. Yeah. So if there was another endpoint, it would stop there, and kind of that's if it's always going to go to infinity is the question. But yeah, no, we would do each interval. So when we see multiple intervals, we would state start endpoint or the two endpoints. If it's going all the way to infinity or negative infinity, we would use that. Now here, up to this point, we've only had one. Yes, one interval, two endpoints, one endpoint, and infinity. Here we have two, yes? Now the way that we join these two is with a U. This symbol here is for union. We're saying that the union of these two, we're putting them together. Both of these are true. It's from negative infinity to -2, union 0 to infinity. These two groups give us true statements. Think of the union, the symbol, as a cut because it's everything goes in. Intersection is the other symbol that we talk with, especially intervals, these sets. It's essentially the U but upside down. I think of it as a cookie cutter. Because we stick it down, only what's inside stays, everything else is excluded. It's only what's in common. Kind of make the difference between the two. Open up is we're pouring everything in. When it's intersection, it's just what's in common. What are we overlap? Kind of. This is would be our or. This is our and. Because we could use the union here, or we could just say, apparently I can't write, or this or that. Questions on graphing these here? Do we feel comfortable with these here? Do we need to see another example of one of these? You good? Or would you like to see one more? Yeah. So again, with the note sheets, I will always put a good number of examples on there. If we need to see another one, we're going to do more. But if at any point, just like with the homework, we feel comfortable with it, we understand it, we're going to move on. But if you do need to see more, we will do more. That's why I put as many example problems in here as there are. So if we look at this next one here, for all real numbers x, such that -6 is less than x is less than or equal to -2. We want to graph it. And this here we can treat like the homework. The first thing I would do for this homework problem is I draw a line, 2 arrows. We have 2 endpoints for the graph, yes? They are what? -6 and -2. So we're going to have 2 lines. Smaller number on the left, bigger number on the right. Now we need to figure out if we're going to fill in these 2 circles at these 2 spots or keep them open. Close at -2 and open at -6. And we know we need to close at the -2 less than, yeah, we have that equal to sign right next to it. Since we don't have that equal to sign between our -6 and x, it stays open. Now where are we going to shade? In the middle. And that's it. Now the main reason I do the squiggle line for shading is just to help us see what's shaded. Because just trying to draw over the top of that line, it's hard to see what it is. Questions on number 4? Yes. So the question is, what's the meaning of the x line, this part right here? Yeah. So that's telling us what type of numbers we're looking at. So here it's saying the set of all real numbers. So any real number, this statement's going to be true. So when we talk or looking at this here, so it's telling me as I just read it, so the set of all real numbers. So any number can work for x. Rational, irrational, or irrational, natural numbers, whole numbers, any of those numbers can work for this here. So telling us what type of numbers are we looking at, this describes it more fully. So the first part, the x bar, is what's our number set. Here's our description of it. Does that make sense? Okay. Well, right, we'll look at number 5. The set of all real numbers, x, such that x is less than or equal to 0, or x is greater than or equal to 10. Still have 2 endpoints, yes? They are 0 and 10. 0, 10. 0 is our smaller number. 10 is the bigger of the two. 2 circles. Are they both going to be open? Both closed? One open? Both closed. They both have that equal to sign, so we'll fill them both in.
Wait, that's what I'm confused.
Yes.
When do I know which shade it is if it's when there's an X?
So when we look at the, so the question is, when do we know when to shade it in? So when we look at the statement or the description, it says x is less than or equal to 0, yes? So for that part of the statement, can x be 0?
Yeah.
Yeah. So at 0, our endpoint, we can fill it in because it says it can be equal to it.
So
Same.
it could be equal to X or whatever. It's shaded in.
So this other one, so on number 4, -6 is less than x, yes? If I filled in -6 for x, would the statement still be true?
Yes.
For this here. So -6 is less than -6. Is that true? No, because it's not equal to it. We can't have x be -6. So at the -6, because it is one of our endpoints for number 4, we leave it open, signifying that x cannot be -6. But if we said x was -2 here, -6 is indeed less than -2. We can agree with that. Is -2 less than or equal to -2? Yeah, because it is equal to. So we fill in at -2 because it can be equal to it. Because on a number line, when we fill that spot in, we're saying that that point is included in the number set. Does that answer that question? Yeah. Sweet. All right, let's look at the other part. X is less than or equal to 0. We would shade to the left. X is greater than or equal to 10. To the right. That's it. You feel more comfortable with these here? All right. Last thing we're going to talk about is actually writing these set builder notations and writing these out. When we write in set builder notation, there's a few things we need. We need to know what type of numbers we have and the description. The description cannot go in there as a interval. So like B, we cannot leave it as -1, negative infinity, comma -1, or -1, comma infinity. We just can't leave it as that. We have to write it as an equation or an inequality. We need one of the two. Now, if they gave it to us as an inequality already, we can just take that inequality and stick it into the description. Now, if we look at A, the set of all integers greater than 5. The set of all integers tells us our group, what type of numbers we're talking about. The description, greater than 5. Okay? Now, our greater than 5, we do need to write it as an inequality. So we'll use x, because x is our normal variable. And we're saying that this variable, this number, has to be what? Greater than 5. So greater than 5. So that would be our inequality description of our types of numbers, yes? And we know that the group of numbers we're talking about is integers, yes? So let's start writing it. So the first thing we have is a brace. Now, up to this point, we've been doing x bar because it's the set of all real numbers. Brace x bar is the set of all real numbers. Are we talking about all the real numbers? No. What are we talking about? The integers. So we can say x is an element of the integers, because that's why it's nice to have these here. So what we have so far, x is an element of the integers such that, what's our description? X is greater than 5. We describe the type of numbers. X is an element of the integers such that x is greater than 5. Okay. Question on how we wrote this here. I like this way better. The set of all x in the integers such that x is greater than 5. The textbook does write it a little differently. And again, I won't count one of these correct and one of these not. The way that the textbook does this is they say the set of all real numbers x such that x is an integer. I missed. Make sure to spell that right. I-N-T-E-G-E-R. And x is greater than 5. Personally, I don't want to write all that. And for the most part, we just took that sentence and threw it into the set builder notation. Can we agree that those two set builder notations are saying the exact same thing? Yeah. Because there are, again, multiple ways to write this. We can still keep the set of all real numbers x such that x is an element of the integers and x is greater than 5. You don't have to write all of them. I just need one of them. But we're seeing there are different ways for us to write this and define this. Because even though both of these second two start off with the set of all real numbers such that x is an element of the integers, we're saying that we're defining x further. Element, a part of, is an element of the integers or in the integers. Yep, so that's our symbol for integers. Z with an extra line is our integers. Our n with an extra line is our natural numbers. Q is our rational. W is our whole numbers, but most of the time we'll just say it's integers if we're talking about whole numbers. Questions on this here? Natural numbers are our counting numbers. So 1, 2, 3, 4. It keeps going. Anything great, so our counting numbers past 1 and greater are positive numbers. We're ready to look at B. We have the interval parentheses negative infinity comma negative 1 parentheses or parentheses negative 1 comma infinity. We have two intervals, yes? So we have to rewrite these intervals as an inequality. So negative infinity to negative 1, we're talking about all the numbers less than negative 1, yes? So we can say x is what? Less than negative 1, yes? Would it be less than or equal to negative 1? Less than, because the symbol after the negative 1 is a what? Parentheses, yes? Parentheses means what? Not included. If it was included, we would have a what? The bracket. Because bracket means included, parentheses means not. So it's not going to be less than or equal to, it's just less than. Because if it's a parentheses, it's not included. If it's a bracket, it is. So if we look at the next one, negative 1 to infinity, we do have parentheses on both. Parentheses after the infinity really doesn't tell us much because it always gets 1. But at the negative 1, we know it's not going to be equal to it, correct? So we'd have our x, and then we'd say x is what? Greater than negative 1. So we understand how we got the two statements, yes? What would we put between them? Well, what was between them before we changed them? So it's still going to be or. It's an or statement. Are you ready to write this in set builder notation? Yes.
The first one, the negative infinity, would that not be like a negative sign for the x?
It would not, because all it's saying is that we're going from, if we looked at it graphically, we're at negative 1 and we're going to negative infinity. So it's telling us we're going indefinitely in that direction. Does that make sense? And that's why we have the negative infinity. We wouldn't put the negative with the x. We're just saying x is all the numbers less than negative 1. And we put the negative next to the infinity saying that we're going down smaller and smaller. The positive infinity tells us we're getting bigger and bigger. Okay. Brace, x. Did it tell us what our number types were this time? No, it didn't tell us directly, but it did tell us. Because we're talking about an interval, yes? So we're talking about all the numbers less than negative 1, which are our integers, our rational numbers, our irrational numbers. We're talking about all the numbers on that line, yes? If we're talking about all the numbers on the line, we're talking about all real numbers. So do I need to put that x is an element of the real numbers? No, we can just put a line, because brace x bar is the set of all real numbers x, such that, because if we're talking about real numbers, we don't have to specify. This tells us enough. All right, you ready for the next part? We have our inequalities. Right here, yes? Put it right in there. That is our description. Because once we get that inequality statement, we just stick it into the description. We're done. Questions on this here? I started filling in the graph. This would be the other half of the graph, yes?
If we get like a question like that, test or something like that, you would want us to draw a graph too?
If it says to draw it, then yes. If it doesn't, no. But if drawing the graph helps get to the inequality, draw it. Although the graph is kind of interesting. We filled in pretty much everything but what? -1. So we're really saying that x, the values of x for this are all the real numbers except so we're saying that x cannot be what? That is the exact same statement, isn't it? Yeah. For all real numbers x such that x is not equal to -1. Both of those are true. Both of those are the same statement. Because if we don't see that we can have that x is not equal to -1 and we write the inequalities, that is right too. Both of these are right. You don't have to have both, you just need one of them. Questions on this here? Let's look at number 6. -infinity, comma, -1, bracket, or parentheses 1, comma, infinity, parentheses. So unfortunately, we can't just stick this into the set builder notation. We don't have it as an inequality. So we need to rewrite these. So this first part here, our endpoint's at -1 and we're going to -infinity. We're going all the way to -infinity. So we're saying x is what? Less than -1, yes? Because it's all the numbers less than -1. Or equal to, because we do have that bracket next to -1, that means it can be equal to it, so we have to put the less than or equal to. Questions on the first half of this statement before we look at the other half? Now the other half, we have 1 to infinity. So here we're saying that x can be, there's going to be, greater than 1. Could this one be equal to 1? No, because the parenthesis next to the 1 says it's not equal to. And again, this is still a what? Or statement, yes? Questions on how we wrote this, these two inequalities? Mm-hmm. The or? So x is just the number. X is just a variable holding in place of the values, how we're quantifying what numbers can go in there. So as we do that there, we're looking at 1 to infinity. So the smallest number for this range is 1, yes? And then they're going up. So x, our unknown, the variable or the number that would go into it, has to be bigger than, so x is greater than 1. Because it's really the x is taking place of whatever number could go in. And the interval is telling us that that x values, the numbers we can plug into it, are going to be from 1 to infinity, or from -1 to -infinity. -1 or smaller, or 1 or bigger, are our two ranges. Does that make sense? Okay. We ready to write the set builder notation? Now we can rewrite it below it, because we can go brace x bar, because we are talking about the set of all real numbers, such that what? X is less than or equal to -1, or x is greater than 1. and that's it. Now, unfortunately, unlike the last one, there are numbers between -1 and 1. We can't just say it's not equal to, like the last one. Because 0, if we say we let x be 0, 0 is not greater than 1, and 0 is not less than or equal to -1. It does not work. So there is a gap between these two statements. We're ready for number 7, and I believe this is the last one. Or there's 2 more, it looks like, but that's fine. The set of all integers except 4, -4. So as we look at this here, what are our group of numbers we're talking about? Integers, the set of all integers. And our description is, except for -4. The only value that x cannot be is -4. Out of all the integers, it cannot be -4. So we do have our, I'm ahead of myself, because we have our brace x, element of the integers. Yep, so our z with an extra line, saying that we're talking about the integers. X, for all x in the integers, such that, what? Not equal to -4. So except -4. So we can have any other integers, but, yeah, not equal to. So except not equal to can't be. We're just saying x cannot be -4. So that's all it's saying. Not equal to. X cannot be. Questions on number 7? We ready for the next one? Writing subsets in set notation. The whole number is 50 through 54. So, some of these here, and especially writing these sets and these subsets, there's different ways we can go about it. And depending on if it's reasonable or logical, we pick which one we can use. Okay? So whole numbers. Whole numbers are our natural numbers plus 0, yes? So if we looked at this here, the set of whole numbers from, or whole numbers 50 through 54. So what would those be? What's our first one? 51. Well, I'd say 50, because 50 through 54. Because I would say between, yes. If it was between 50 and 54, say 51 would be the start. 50 through 54, we're going to include 50 and 54. Yep, we're going to include 50 and 54. So the first one would be 50, yes? What's the next one? Then? Can I list those? Is it easy to list all of them? Do I need to do the whole set builder notation? No, because I can go 50, 51, 52, 53. We can list them out. And we can do this easily because I can list all 5 numbers and get them all. If it said the integer numbers 50 through 54, would it be any different? Now, integers and whole numbers, they are the counting numbers, are same thing. If it said the real numbers 50 through 54, okay, now we're going to have to do set builder notation because we have to include all the numbers between 50 and 51, 51, 52, so on. But here, whole numbers, I got them all. Which one? Oh, if we wanted to do set builder. So if we did all real numbers instead of whole numbers. So we would start off with brace x bar, yes? But we need a way to describe 50 through 54 as an inequality. But we do have 2 endpoints, yes? One of them is what? 50, the other is 54, and we're saying that our variable is in Middle, yes? So we're saying that 50,
So it's greater than or equal to 50 and less than or equal to 54.
because 50 is less than or equal to x, because that value that we can plug in that's going to make this true is going to be bigger or equal to 50, but it's also going to be less than or equal to 54. It's between the two. Do we see how we wrote that? Okay. And then we would just say and that's it there. We just turn it into an inequality and throw it in there.
Could we use that for this question?
Yeah.
So it'd be like the same answer.
So if we talked about whole numbers, x is an element of the whole numbers such that 50 is less than or equal to x is less than or equal to 54. But since we were able to list them out, I think it's a little bit nicer to just go 50, 51, 52, 53, 54, brace on both sides, call it good. Good question. We feel good about A? Before we look at B? The real numbers 0 through 4. Hey, we actually just talked about this, didn't we? So 0 through 4, we do need to write it as an inequality. We do have two distinct endpoints, and our numbers are going to be between them, which means our unknown, that x, has to be between them. And we're saying that whatever that number is, it's going to be bigger than 0. 0 is going to be less than it. But whatever that number is also has to be less than 4. Can it be equal to 0 and 4? Yeah, because it's 0 through 4. So we'd have the equal to sign. We have this statement. Yes? You ready to write it as set builder? We have the inequality there, don't we? And it's all real numbers. Is there anything saying I just can't stick the brace X bar in front of it? What's the only thing it's missing? The brace after. Yeah. We just haven't been doing that on the previous ones. We could have. Questions on this here? So negative 100 through 100 is the exact same thing we just did. Because we'd say what? Negative 100 is less than or equal to 100. So we would say that x is an element of the integers. For all x in the integers such that negative 100 is less than or equal to x is less than or equal to 100. Now we would use this, and according to the book, we would want to use set builder notation because, well, there's 201 integers from negative 100 to 100. Might not be logical to actually write them all out. But, questions on anything we've done? Homework is on page 7. Problems 5 through 14. 5 and 6 use braces to list the elements. So the set of integers greater than 50, we can write it in set builder notation, or we can say kind of brace 50, 51, 52, 53, dot, 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 dot. Well, it'd be 51, 51, 52, 53 going on. Brace. Done. Same with 6. 7, 8, 9, and then 7 through 14. Write the interval in interval notation. So they're either going to give you, the first four are going to give you inequalities. You're going to write it in interval notation or parentheses and brackets. 11 through 14, they give us a number line. We're doing the same thing. 17 through 24, sketch the graph. So I do want you to sketch the graph of 17 through 20. There, you draw the number line, shade in the region, fill in the circles or leave them open. 21 through 24, write the set of numbers in set builder notation, kind of like what we did at the start of class today. And the same is true for 26 and 27. That's it. All right? Yes, sir. Okay, I can run one off. I don't have any extra at the moment.
So just
5 through 14, 17 through 24, 26, 27. Yes. Yes. Preferably, I would like it on a different piece of paper. Yes. Now, for the most part, most of this here, there's not a lot of scratch work, and that's fine. Yes. Thank you. If you do have your syllabus, I will take those.